It's a simple formula. As far as we understand it, there can be no life without water. All the more exciting, therefore, is the fact that experts have now discovered a whole range of extraterrestrial worlds where the cool liquid slush is about. These include the nearby super-Earth TOI 1452b, which is not only suspected of being a full-fledged ocean planet, but is also located in the habitable zone of its home system. Could the dripping wet exoplanet have even produced life? And what is the real story behind the exciting discovery on the water world K2-18b, which could actually turn out to be the first discovered extraterrestrial biosignature? Although the history of the search for exoplanets is still comparatively young, researchers can already look at a truly impressive list of alien worlds. What began in the early 90s with a sensational discovery around the pulsar B1257+12 now includes more than 6,900 planets orbiting a host star other than the Sun. Most of them are rocky planets or large gas giants. But despite this, many astronomers assume that there are still countless unknown water worlds out there, and that these may ultimately be even more common than rocky planets. Indeed, a few years ago, a team of experts led by Charles Cadieux from the University of Montreal succeeded in adding a spectacular entry to the ranks of these exciting ocean planets. More specifically, the researchers focused their attention on the data collected by NASA's TESS Space Telescope in a binary star system about 100 light-years away in the constellation Draco. Every 11.1 days, the light from the two dwarf stars TOI 1452 and TIC 421125589 was dimmed for short periods. And of course, astronomers know exactly what such regular brightness fluctuations mean. After all, they often provide the crucial clue to a transit and thus to a planet passing in front of its parent star. To test this assumption, scientists analyzed the double star system using the telescope at the Mormagantic Observatory in Quebec and the SPROU spectrometer of the Canada-France-Hawaii telescope. The result was exciting. The experts actually recognized that the object responsible for the brightness changes is not just an exoplanet but a super-Earth. But be careful. The term super-Earth does not refer to the surface characteristics or habitability of a planet, but only to its mass. Specifically, the celestial body must weigh at least as much as the Earth but less than Uranus, falling within a mass range of 1 to 14 Earth masses. Is TOI 1452b an ocean planet? That is exactly what the analysis of the spectral data revealed at the time. Since then, we have known that the exoplanet named TOI 1452b weighs about 4.8 Earth masses and is 1.6 times larger than our earthly home. So far, so very much in the astronomical frame. But at the same time, a special detail caught the eye of the experts, which immediately made them suspicious. Based on the determined dimensions, the planet has a density of 5.6 g per cubic cm, which, to put it mildly, is surprisingly low for a celestial body of this size. After all, a typical super-Earth with an iron core and a thick rocky crust actually has a much higher density. How, then, can the surprising ratio of TOI 1452b be explained? According to Charles Cadieux, there are three possible approaches. The first is based on the assumption that the planet has no iron core and consists almost entirely of rock. The second on the assumption that it is only about the size of Earth and has a thin but extensive gas envelope. But the third theory, and this is the exciting one, is that astronomers have caught a full-grown ocean planet in their net. In fact, this is anything but unlikely. The researchers state that the parent star also contains iron. And given this, it would be uncharacteristic, to say the least, for a planet with such a low iron content to form in this constellation. The assumption that the low density of TOI 1452b is due to a high proportion of water or hydrogen seems much more promising. Accordingly, we're dealing here either with a rocky planet with a lot of atmosphere or with a celestial body that is completely covered by an ocean and consists of almost 30% water. And since the temperatures on the super-Earth are comparatively mild, 50 degrees C, experts consider the latter scenario to be the more likely one. Just to be clear, although our Earth is known to be 3/4 covered by water, that doesn't mean that this is also its water content. In fact, this is just 1% overall. Applied to the 30% of TOI 1452b, this means nothing other than that its seas would have to be significantly deeper than their earthly counterparts. On paper, TOI 1452b could thus not only offer abundant liquid water but also, as a result, life-friendly conditions. But in reality, this intriguing assumption is still awaiting its final confirmation, as further follow-up studies are needed. However, the fact that such follow-up investigations undoubtedly have the potential to bring groundbreaking things to light has recently been demonstrated by a team of astronomers elsewhere. After all, they have succeeded for the first time ever in proving the actual existence of water in the atmosphere of a nearby ocean planet candidate. To do this, the research group led by P. Alexis Roy, who, like Kaju, works at the University of Montreal, used the Hubble Space Telescope to examine the light spectrum of the exoplanet GJ1214b, which is 97.7 light-years away. More specifically, the experts had developed their observation program not only with the aim of detecting water molecules in the gas envelope, but also to search specifically for water vapor. The fact that the exoplanet, which weighs around 3.4 Earth masses and was only discovered in 2017, was a welcome research subject is due to its orbit. As seen from Earth, it passes directly in front of its sun-like central star, enabling scientists to detect the spectral signatures of its atmosphere in the starlight. Indeed, Roy and his colleagues managed to score a sensational hit in this way. The planet spectrum showed a striking absorption line at 1.4 micrometers, indicating the existence of water. However, the researchers emphasized that the data could also be explained theoretically by a hydrogen-helium atmosphere with a few water molecules. But the other characteristics of the spectrum strongly suggest that GJ1214b actually has a water-rich gas envelope. This is partly because the celestial body is anything but a planetary youngster. It has been around for some 6 billion years and orbits its host star at a comparatively close distance. The star's intense radiation should have long since torn the planet's original hydrogen envelope into the depths of space. Added to this is the fact that the spectral features only match a hydrogen-helium atmosphere if it has a dense cloud cover, which, according to our current knowledge, it most likely does not. And so it comes about that, according to the experts, everything really does currently point to GJ1214b embodying an alien world on which the cool liquid slushes back and forth in vast quantities. This also makes the planet the first water world candidate ever for which the water signature of a water-rich atmosphere could be detected. At the same time, this is also the smallest exoplanet in which molecular signatures have been detected in the gas envelope. Beyond doubt, a potential biosignature. But what does the exoplanet actually look like in detail? Well, researchers estimate that the celestial body was once formed further out from its parent star, beyond the so-called snow line, which allows the formation of water and ice-rich planets. Consequently, GJ1214b could consist of half water and half rock, reminiscent of Jupiter's moons Europa and Ganymede. After its birth, the planet is thought to have migrated to a more inner realm before finally reaching its present position. However, this also caused it to heat up significantly, and the temperatures of up to 400 degrees Celsius caused most of its primordial ice and water to evaporate. In other words, the planet could correspond to a hotter version of the solar system's icy moons. And what's more, it could also hide another exciting secret beneath its surface. Just like Europa and Ganymede, GJ1214b could have a gigantic ocean under its crust, and that would already be its second. Whether this sea sandwich really corresponds to reality, however, remains to be seen in the future. And in this case, the future goes by the name of the James Webb Space Telescope, which, with its high-resolution infrared instruments, can provide even more detailed spectral signatures of water and other molecules. But the James Webb Telescope can also provide groundbreaking evidence for the existence of extraterrestrial life. Yeah, you heard right. Webb has indeed detected traces of dimethyl sulfide, DMS for short, on the water planet K2-18b, and thus traces of a sulfur compound that on Earth is produced exclusively by organisms. To be more precise, DMS is produced on our home planet by marine plankton and when organic substances break down. But does the fact that we have now discovered this very compound in the depths of space mean that what is arguably the oldest question of all time has now been answered? Can we finally answer the question of whether we are really alone in the universe with a resounding no? Well, unfortunately, it's not quite that clear yet. The DMS signal in the Webb data was not particularly pronounced, and it also overlapped very strongly with the signal from methane. And since the values of both molecules cannot be clearly separated, a definite proof is still pending. But even in the astronomical world, postponed is not abandoned. Fortunately, Webb's MIRI spectrometer is capable of detecting the signature of dimethyl sulfide and its byproducts in the mid-infrared range, and thus providing significantly more clarity in the DMS-methane confusion. And that is precisely what it should do in the near future, possibly providing us with the answer to a question that has been bothering us Earthlings for thousands of years. The question of how you will never again miss a new video from us no longer needs to bother you, though. Just click the thumbs up and subscribe now to never miss a new video. We'll see you soon.